right. Okay, so good evening, everyone. We will start very soon. Let me see. Just let me change something. Okay, all right. So a few of you had some questions from earlier, so thank you. So I'll go in that order. First question was find the area of an equilateral triangle if one side length is given, so, or radius. Okay, so here's an equilateral triangle. And let's say the side length is 8 on each side. 8, 8, 8. You could actually do this two different ways. You can do 1/2 side length, the apothegm, and the number of sides or number of triangles, or you can do 1/2 base times height. So you have two scenarios. Now, if you do the side length and the apothegm and the number of sides, you must have a center, a dot, and then you make your apothegm, which is 90 degrees to the side, and then your radius. And so in this situation, you have to do a little bit of calculating. This angle in the middle is going to be 360 degrees divided by number of triangles or number of sides, which is 3. You get 120, but then you have to divide that by 2 after to get 60. I know Mr. McKee or Miss Bratcher or Mr. Higgett, they do it where they say do 180 divided by n, number of sides. So regardless, you'll get 60 degrees there. Now to proceed, we know that 8 gets split in half, so now this is 4 and 4. And we have to work backwards to figure out the apothegm. Ooh, this is not the best answer. So if you look at your 60 degree, that's across from the 4. So to get to the smaller side, you have to divide by rad 3. I didn't pick the good number. And then you can't keep that in that form, so then you'll do 4 rad 3 over 3. That's the apothegm. So we found it. And then we don't even need the radius. So now if we were to use this formula, we would plug in 1/2. The side length is 8. That was given. The apothegm we found was 4 rad 3 over 2. And the number of sides or number of triangles that will be are 3. So what you'll do, especially in this case, you'll want to leave your answer in rad form, is you will multiply all the numbers except the rad and divide all the numbers except the rad. So that means we will multiply, sorry, I'm just getting a different color. We will multiply 1/2 times 8, which is 4. And then 4 times 4, which is, oh wait, hold on, this is a typo. 4 times 4, which is 16. And then 16 times 3, which is 48. And then 48 divided by 3, which is 16. So our final answer will be 16 rad 3. I didn't put any units, so square units. Final answer. Now, if I wanted to do 1/2 base times height, I'll do the same exact one. We will get 16 rad 3. Okay, so again, we just did an equilateral triangle. We found the area. So a totally different way is if I want to do 1/2 base times height. I already have base. I already have, right, half the answer. So I will cut this in half, this equilateral triangle in half, and this makes it 30 degree up here and 60 degree down here. So now to find the height, this is 4 and 4. So now I would multiply 4 by rad 3, and well, boom, that's my height, 4 rad 3. And we are going to get the same exact answer. If you take half of 8, that's 4. And then 4 times 4 is 16, and you leave the rad 3. And there it is, same exact answer. To tell you the truth, this is a little easier than the 1/2 AP or the 1/2 SAN. So hopefully, where did Alexander. Alexander, hopefully that made sense, okay? Max, yes, we could use Heron's formula, but most likely this one, you don't want to get a decimal, and you want to leave in rad. But you know what? Heron's formula will give you a rad, huh? So we could have done Heron's formula. So someone asked Heron's formula earlier. So that one, going a little out of order, sorry. But Heron's formula, oops, this is all 8s. We would have done first, find the half the perimeter. So half the perimeter is 12. So we know what S is. And then now to find the area, we would do S times S minus side A, S minus side B, S minus side C. Normally, we wouldn't do it for equilateral triangles, but I'm just showing you you could do it this way. So we would have, under the rad, we'll have 12 times 12 minus 8, 12 minus 8, 12 minus 8. So you put just everything in the calculator, it'll be 12 times 4 times 4 times 4 times. So that's, let's see, 768. Okay, so that's under the rad. So I'm going to go to the next page. So 768. And I think we could simplify it. I know it's very large, but let's see. So this could be simplified to 16 rad 3. How amazing is that? So you could do, this is rad 256 and rad 3, and that simplifies to 60 rad 3. So yes, Max, we could do it with the Heron's formula. It's just a little bit more intense. I feel like it's unnecessary, but yeah. Okay, so because originally, I mean, you can, and you could put this in your calculator and you'll get a decimal, which is the same exact thing. So if you do rad 768, you'll get 27.7, which is the same as 16 rad 3. Yep, same exact thing. So rule of thumb is certain things you should have your brain triggered to use rad form. For instance, you have an equilateral triangle, you know that you'll have 30, 60, 90s, or you will have 30, 60, 90s using 1/2 base times height, or 1/2 side apothem number of sides, or 1/2 apothem times perimeter. So because of the 30, 60, 90, your brain should trigger that you're going to use those special right triangles and you're going to have rad answers. That should be a trigger for your brain. Okay, so for equilateral, you should use those 30, 60, 90s to get a rad answer. It's not wrong to say it's a decimal answer, but that's your top priority, rad answer. Another rad answer is for if applicable, but for squares, if applicable, because you'll end up with a 45, 45, 90, and you'll do 1/2 side times apothem times number of sides. Another way you can do it is 1/2 d1, d2, right? Diagonal 1, diagonal 2, because the square is a rhombus, so it shares the same formula. Or if you're given base and height, just do base times height. That's the best if you have those given or if you could figure them out. Okay, so that one again should have a rad answer or a whole number, okay, because of the 45, 45, 90. Then another one that should trigger your brain is regular hexagons. So that one you will create 30, 60, 90, and you will have to try to use rads for your final answer. So those 3 shapes, triangle, square, hexagon. Sorry, let me elaborate. Equilateral triangle, square, and a regular hexagon. Those are the rad answers. Okay, let's go over the SAS formula for a triangle. So that's if you're given, let's say, 71 degrees and 5 and 9. So basically, this is 1/2 base times height. We have base, which is 9. So we have half the answer again. But we have to figure out what height is. We don't know what that answer is. So here's the elaborate way, and then I'll cut to the chase later. So if we need to find the height, we're going to have to use trigonometry, SOHCAHTOA. I'm going to put H here. So if you look at the red triangle, I have opposite over hypotenuse. So that's sine 71 is equal to opposite H over hypotenuse 5. Cross multiply, you do your math, you'll get H, your height, is 5 times sine 71. So woohoo, we found the height. And so we have 1/2, the base is 9, and the height is 5 sine 71. So that's the manual way, that's the long way to do it, but cut to the chase. The side angle side formula is 1/2 BC sine A. So 1/2 side B, which is usually the base on the bottom, side C, which is the other side that you're given, and then sine angle A. Now this here, whoops, this here is basically your height right here. See how it's C and then sine angle A. So it's the same. These are identical, 1/2 base times height. It's just this is the fast, quick way. So if you didn't find the height for the next one, let's say I had this as 62 degrees and 4 and 7. Oh my gosh, this is what you could do so fast. You could do 1/2 BC sine angle A. So you'll get 1/2, your base is 7, side C is 4, and then sine 62. But once again, all of this underlined item, that's your height. So it will always be sine. That is correct, Brianna. It will always be sine as long as you're given a side angle side, and as long as you're using that angle they gave you to find the height. It will always be sine, yes. No, it's not for right triangles. No, this is for non-right triangles, actually. Because if you have a right triangle, please just use 1/2 base times height. So this is a normal one. If this was like 9, this was 4, you're given the height. This is not the side angle side situation. You would just do 1/2 9 times 4, and you get 18. But what I was demonstrating was a non-right triangle, and you were given, let's say, a 72 degree and an 11 and a 6. This is not a right triangle. This is not a right triangle. So you would do the 1/2 base times height, which is also known as 1/2 BC sine A. This is for a side angle side triangle to find the area. Okay, all right, the next one was number 14 and number 16 from the quiz. Let me find my quiz. Let's see. Okay. So I hope Delaney, oh, from classwork. Oops, okay, I misread. Classwork. So I'm not sure if everyone received this, but this was a very long paper, and it had someone, like handwriting, like it wasn't typed, and there were 24 questions. They're all like in boxes. If you don't have it, here it is. So Delaney was asking for Tira Tira classwork 3. And the title at the top, it says like chapter 10 quiz review or something like that, geometry honors. So she's asking for 14 and 16, and those are some thinkers. I'm not sure if those are going to be on the test, but these are good review problems. It asks to find the area of the triangle. So we were given right triangle. This is 6 and 2. So we have to use 1/2 base times height. Well, we already have half the answer. This whole bottom is 8. That's your base. We just don't know height. We have to find out what height is. So I'm going to put H. So this is where a long time ago, chapter 7, back in the day in January, when you had to compare your similar triangles. That was a similar triangle, And some teachers call this geometric mean, so maybe that triggers something in your brain. So what you'll do is step 1, 6. Look at how it's touching the 1 angle and the 90. That will match. Oops, I made my markings wrong. Let me change my markings. This is just 1 and this will be 2. So the 6 matches with the H. Those are like corresponding sides. So I don't know what H is, so I'm finding H right now. So I'm doing 6 over H, that's a ratio, is proportional to H matches with 2. So that's H over 2. So this looks familiar. This is geometric mean. Cross multiply, you'll get H squared is 12. So H is rad 12, which H would be, what is it? 2 rad 3? 2 rad 3. So that's the height, 2 rad 3. So now we multiply all those numbers, half times 8 times 2, that gives you 8, and you leave the rad 3, and that's our final answer for the area of the triangle. So the side step is a chapter 7 prior knowledge. Okay, the next one is number 16 on Tira Tira classwork. You might have gotten this paper from your teacher, maybe today, I'm not sure. If not, here's a new problem. So number 16, this is also another prior knowledge. It's asking us to find the area. And let's say 48 and 62, and this is 10. So you're like, oh man, I only have 1/2 base. I only have 1/2 times 10. I know the base is 10. So in order for me to find the height, I have to find another side. So before I do that, I'm going to have to calculate this angle. That's easy. You know that the sum of the triangle adds to 180. So 48 plus 62, that's 110. Subtract that from 180, and that's 70. So that top angle is 70 degrees. So I either find X over here, or I find X over here. It doesn't matter. It won't matter at all. So I'm just going to place an X here, and I want to find that length. So that means I have to go back to chapter 8, which is February. How do you find the missing side? It's not a right triangle, so it's not SOHCAHTOA trig. It's law of sine or law of cosine. In this case, we have to do law of sine with the given information. So I have sine of 62 degrees, and across the street is side X, equals sine of 70 degrees over side length 10. So you cross multiply and you get it all ready to go. Sorry, I'm skipping a step here. And then that value is going to be a little bit smaller than 70 because 70 is the biggest, so 10 is the biggest. 62 is a little bit smaller, so that across the street will be a little smaller. So I'm just estimating, I'm just plugging it in. This is about 9.396. So 9.396. 396. But bummer, that's still not the height. So I did all that just to get the height. However, that isn't the height. So what are we going to do, right? So if we, let's see, let's go back. So now this is about 9.36. Oh gosh, 9.396, and it keeps going, right? So from here, I have that calculator. I have that answer in the calculator. I'm going to have to go to the next page. Sorry, guys. So I have 48, 62. I just found this was 9.396 still in my calculator. And then now I need to find the height. We just did this earlier. So we're going to use this triangle over here. And we're finding the height. The bottom was, I forgot the number. Bottom was 10, so we don't need that 10 anymore. We're just trying to find the height. So we're going to do sine of 48 degrees equals to h over 9.396, dot, 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 dot. It's still in my calculator. H is 9.396. It has not deleted yet. Sine 48. So don't, especially to your TRS class, but don't round until the end. Don't put 9.4. It might change your answer. Don't put 9.4. So I have that in my answer, 9.396, and I'm going to push times sine 48, and I get 6.98. I know it's like pretty much 7, but if you approximate too early, your answer will be kind of off. So then I'm going to do that answer, right? I did not delete it, times 10, and then divide 2, and I get 34.9 instead of 35. Oh, I don't have units, but square units. Okay, so that will be your final answer. So again, the whole bottom was 10. We just found the height doing SOHCAHTOA, but before doing that, we had to find this missing side. Okay, all right, so the next problem I have is Kyle's homework, but Kyle, I don't know if you're still here. I don't know if you ever answered my question. I don't think you did. So Kyle, you earlier said question from today's homework, finding the base lengths if the sum is 18. Also, one is 3 times longer than the other. Oh, is that one problem? Maybe. Okay. So I don't think we're not given enough information. It's 4.5. Hold on, let's see. Find the base. I mean, what shape is this? Okay, let me try to look for it in the homework. Some of the bases are 18. So Andrew, do you know what shape this is? Oh, trapezoid. Okay, thanks, Kyle. So trapezoid. Ah, so we already have the sum of the bases. B1 and B2 are already given. This is so great. All right, so the formula for trapezoid is half B1 plus B2 times height. We already know this answer here is 18. Oh, and the height is already given? The height is already 6. So then we would just have to type all that in your calculator. So if it's not asking to find the specific base, like, find base 1 or find base 2, then all we're finding is area. We're just going to multiply these 3 numbers. So the sum of the bases is 18. It's already given. And then we just multiply half times 18 times 6. And yeah, the answer is 54. Yeah, this was actually easier than I thought. But then you included some other words to that, and I don't know if that relates to the problem. So I'm not sure, Kyle. I don't think the one is 3 times longer than the other. That was something we did on the warm-up today for Tira Tira, but it's not part of the number 14. By the way, this is number 14 on today's homework. Okay, so if you find something, Kyle, let me know. 1 to 4. Oh, it did say. Oh, okay. It did say how about let's do an extension to this, okay? So although it did say all that stuff, sorry, Kyle, now I read the question. It did say one base is 3 times the length of the other base. So if it asks, I'm doing an extension. This is not the homework. Okay, so we know the sum was 18. And if now my next question is, let's find one base length. So is it 9 and 9? No. Is it, 2 and 16? No. Like we could guess and check all day or do it algebraically. So I'm going to call one base x and the other base 3x because it's 3 times bigger. So now if I do a little bit of algebra, and this is an extension question, this might be helpful for tomorrow's test, by the way. You might have to do something like this tomorrow. So then the sum of x plus 3x is now 4x equals 18. And then we're trying to find one base length, okay? This is an extension question. So x would be whatever 18 over 4 is, and that's when Andrew brought up 4.5. So thank you, Andrew. That is accurate. So one of the shorter bases is 4.5, and the longer base would be 13.5. And if you add them, it's 18. And if you do 4.5 times 3, then that'll be 13.5. So that's just an extension, okay? But we didn't need it for the problem. That one sentence was really negligible. We didn't need it. It was not really important. All you needed was the sum of the bases. Okay, Kyle? Do we need, okay, so a couple questions I missed. Questions like this going to be on the test? I don't know. I don't know now what we're talking about. Sorry, Ryan. And then, Andrew, will there be lost signs? There could be possibility. Low chance, but it is a possibility that some old stuff could come back. So we want to keep all your prior knowledge still intact. Okay, there's a couple more things. Let's see. We did herons earlier, so hopefully that person was here when we were doing that. Go over skill factor, yes. Let me do the quiz questions because that was V's questions. So let's do quiz. Number 10, 11, 15, 20. Okay, so quiz. Hopefully this is the same quiz as yours, V. If it's not, please stop me. So here is a square, and they were giving us the radius of 12. So the radius is 12. Okay, from here, what we need to do is find the area of the square, and I have a very quick strategy. So since it's a square, that means this other part is 12, this other part is 12, this other part is 12. Now, you could do this in so many ways. You could do 1/2 d1 times d2, or you can cut it up into the apothegm and do 1/2 side times apothegm times number of sides, or 1/2 AP. Or you can do, if you find the outsides, you could do base times height. Since I have all the diagonals, I'm going to do this. There's 3 different scenarios you can do, 3, but I'm doing scenario 1. So in this case, now D1, I'm doing it a different way than maybe your teacher has shown. You can do this in different ways, okay? So D1 is 24 and D2 is 24. Therefore, your answer will be whatever 24 times 12 is. And that is 288. Final answer is 288. Now, if you did the 1/2 AP version, you would have to have gotten these side lengths. So this would have been 6 rad 2 because you're dividing by rad 2. The apothegm would have been 6 rad 2. And then you would plug it into here. So I'm going to erase this. 1/2, 12 rad 2 for the side length, 6 rad 2 for your apothegm, and 12. A little bit more complicated, a lot more numbers to look at. So 12 times half is 6. 6 times 6 is 36. 36 times 12, oh my gosh. 36 times, where did I get 12? No, not 12. 36 times 4 is 144. And rad 2 times rad 2 is 2. So that's 288. But it's very messy. Okay, and then the last one, if we did base times height, we would have gotten, let me see, this would have been 12 rad 2. The outside is 12 rad 2. So 12 rad 2 times 12 rad 2. You do 12 times 12 is 144. Rad 2 times rad 2 is 2. So 144 times 2 is 288. No matter what method you do, you should get 288. Yes, proportions. Maybe the one where you had to look at the triangle a different way to find the height of the quiz. First one. Oh, okay. Yes. All right. So Ryan, I'll come back to you, and then Cody, I'll come back to you. Will we ever have to solve? We're only given one side of the triangle. What kind of triangle, Una? What kind of triangle? Okay, I'm not sure. Still typing. Okay, So number 11, this is a triangle. This could be done in different ways too. You're given 12. So you could, I'm going to do two different versions. You can do 1/2 base times height. Or you could do 1/2 side apothem, number of sides. So if you do 1/2 base times height, we know this is a 60 degree and a 30 degree. And we could split the bottom 6 and 6, and the height would be 6 rad 3. So this is 1/2. 12 is the full base on the bottom. Height is 6 rad 3. And then you multiply half times 12, that's 6. 6 times 6 is 36 rad 3, final answer. The other way is if we do the 1/2 AP or 1/2 SAN or whatnot. So we know this is 6 and this is 30 degrees and 60 degrees. So we would have to divide by rad 3. So 6 divided by rad 3 is 6 rad 3 over 3. So that's 2 rad 3. The apothem is 2 rad 3. The side length is, the total side length is 12. And then the number of triangles or number of sides is 3. Sorry, my 3's are very, very messy. So we would do 1/2 times 12, that's 6. 6 times 2 is 12. 12 times 3 is 36, and you have rad 3. Same answer, just different methods. Okay. Yes, they only gave one side. Oh, but this is equilateral. This is equilateral, so we have to assume all sides are 12, 12, 12. This was equilateral. It said it's regular, a regular polygon. Cool. Thanks, guys, for helping out. Una never answered. So maybe Una, will we ever have to solve where we were only given one side? Yes, we do. And that will be a regular triangle, meaning equilateral. So if you're given just 12, you have to assume all of the other sides are 12. Yep. Okay, all right. Number 6 on what, Matt? Number 6 on the quiz? Okay, so number 6. Okay, I just did 11. Yes, quiz. Okay, so I will add on to this. So 6 and 17 to 19. And then that'll answer the scale factor questions. Cool. And then I have to answer the Ryan's question later too. Sorry, I'll be back for that. Okay, so next one is number 15 on the quiz. Okay, 15. 15 is, oh, this is, okay, pay attention if you're asking about Heron's formula. This is it. This is the time. So this is when you're given all sides, side of a triangle. So it gave us 8, 6, and 12. So step 1, you have to find half the perimeter of your triangle. So half of 8, whatever 8 plus 6 plus 12 is, that is half of 26. So that's 13. That's step 1. Then step 2 is now area time. So that is this weird wonky formula. You do S times S minus side A, S minus side B, S minus side C. So technically you could get a rad answer from this, right? You could not put in your calculator and you could keep it in rad form unless it says round to the nearest tenth. So we already have S, so I'm going to plug it in. I have 13. 13 minus 8. 13 minus 6. 13 minus 12. I don't know, Rihanna. I have to look at that. I have to do an example, so we'll see. 7, good question. All right, so 7 times 5 times 7. Wait, 13 times 5 times 7 is 455. And I know on the quiz, it asked us to round to the nearest tenth. So in this case, we didn't have to leave it in rad form. So we would do square root of 455. And the final answer was 21.3 square units. Okay, so that one, whoa, that one is nearest tenth. But if it wanted in rad form, we would do rad 455. Let's see. Next one is 15. I'm just going in order how people asked it. So next one is 20, and then I'll go back to 6. So number 20. Okay, pay attention if you need help with hexagons, regular hexagons. So they gave us the area. That's cool. 150, rad 3. And they gave us the perimeter. Oh my gosh. So if you know your formula for regular hexagon, then you're set. The formula is 1/2 AP, or 1/2 SAN. So that means I have everything but the A. I'm trying to find the apothem. So 150 rad 3 goes on the left, 1/2 on the right, A on the right, and 60 on the right. So let's figure out what's half of 60. That's 30. And then there's the apothem, one, little a. And then I'm going to do algebra to solve for a. So I'm going to divide both sides by 30. So that gives me 5 rad 3 is the apothem. Ooh, I found it. That's part A. And I'm not writing any units on the today, but make sure Tira's class is very picky about units. So write inches or square inches, okay, depending on area or side. Okay, now what's the radius? So now this is when you want to have a visual. So I have the triangle in here. I just found this is 5 rad 3, the apothem. And then I know this is a 30, 60, 90 triangle in here. So now to find the radius, I have to find this short side first, right here. I'm going to divide by rad 3. That's easy. That's just 5. And then I'm going to multiply by 2, and that's 10. So the radius would be 10. The radius is touching the center to the vertex. That's the radius. Okay. Okay, number 6, 17 to 19. Okay, so, and then 17 and 19 is the ratio and scale factor. So I know those who are waiting for that. Be patient, I have a little bit more. So number 6 from the quiz, that one was, I think this one, there was a little flaw. Some of you really, really awesome students were thinking a little bit outside the box. But the flaw was we did not need 8 and 6 out here. That was the flaw. Because you will get different answers. So I know last minute I told my students to erase these because really this is a simple problem where you're doing the rectangle, which is 8 times 5. The area is 40. And then the triangle on top, you're like, oh shoot, what's the base? Like, how do you calculate it? You don't. It's just 8. It's the same as the bottom. So this will be 8 times 5, but you have to half it. So 1/2, 8 times 5, and that's 20. And what you do is you have to add them. So the total is 60. Now, that was the flaw because some of my really, really cool students who was doing this, thinking outside the box, they didn't notice that the bottom was 8, and that's okay. So they went out of their way and they did Pythagorean theorem, which was really what I was really amazed. But I'm like, oh shoot, that's not what the intent was. So they did Pythagorean theorem and they got like a really random rad 59. No. I did my math wrong. Rad 39. So they got rad 39 here by doing Pythagorean theorem. And then this was 6 and this was 5. So they did Pythagorean theorem and they got rad 11. And I was really happy for them, but at the same time, I was like, oh no, I needed to erase it. So this was a flaw. This was a flawed question. So, but if 5 wasn't, no, let me see. No, I take it back. Yeah, if 8 wasn't here, then yes, what they did was absolutely awesome. And they now have the base, which is a weird number. But that would be your base times the height. Isn't that crazy looking? And then 1/2. That would have been the area of the triangle. Crazy, crazy. But again, the intent was to not have those on the sides. So sorry if that confused you, but that was not supposed to be there. Okay? All right, now let's shift gears. Scale factor time. So I'm going to do the quiz ones and I'll make up a couple more other ones. Okay, so 17 to, I don't think I did 20. 17 to 20, these are all scale factor and ratio ones. Okay. All right, so scale factor, very important. Scale factor is just when you're given sides of, your shape and you make a ratio. So, or a fraction. So make sure you reduce it. Okay, make sure you simplify it. Make sure you reduce it. So, if it's 2/4, make it 1/2. If it's 3/9, make it 1/3. Okay. Then if you have that answer and if it's asking you what's the ratio of the perimeter, it's the same exact answer. And if it's ratio of the area, you got to do one step extra. You have to square the numbers. So, for instance, if scale factor was A/B, ratio of perimeter would be A/B, but ratio of area will be A²/B². Okay, so here it is, number 17. You were given a pentagon, and they said they're similar. This says the figures are similar. So this was 6 inches, 15 inches. So boom, first question was, what's the scale factor, part A? So right away you look at these two numbers and you make it a fraction. But that's not your best answer. You need to reduce it. So divide the top by 3, divide the bottom by 3. You're reducing this fraction. You get 2/5. Final answer, 2/5. It's not wrong, 6/15. But later your answer will be very large. Okay, numbers will be large. Then next question was ratio of perimeter. It's the same answer. So don't even do any math. It's 2/5. So if I asked you to find the perimeter, and then make it a fraction, it would reduce to 2/5. Last one, ratio of area. A little bit of math. You have to square the top answer, and you have to square the bottom answer. So that will give you 4/25. Final answer. If you did not reduce, you would have gotten 36/225. If you did not reduce, you would have gotten 36/225. But if you reduce that answer, it will end up being 4/25. So it's just helpful to reduce your fractions, okay, before you do any other moves. How do you watch it? I will put a link right after time is up. So in about 10-15 minutes, I'll put a link in the chat box and then you could click it and you should be able to rewatch it. Okay, so next one is number 18. So again, scale factor and ratios and all that stuff. So number 18 said the areas of the octagons, you don't even have to draw it, but I will. The octagons, the area are 72 and 128. And it asks for what's the scale factor. So because we're given area, we are able to find ratio of area. So what I do is I write it as a fraction. But remember, always reduce it. So you could divide the top by 8 and divide the bottom by 8. Let me see. Yep. And then now that's your ratio of area, but that's not your final answer. Now it's asking for scale factor. So let's go review again. Ratio of area is when the numbers are squared. Scale factor is when they're square rooted, or that answer. So your scale factor is the square root of 9 which is 3, and the square root of 16, which is 4. So that's the way to go about it. It would be really difficult to square root 72 and square root 128. You would get really, really ugly answers. But you could do it that way. It's just going to be very ugly. So an alternative, if you forget to reduce, hope you don't, but if you forget to reduce, you would get, oops, that's the wrong answer, 6 rad 2 for rad 72, and 128. 128 by, oh, 64. So 8 rad 2, right? And then you would, what's it called? Reduce, and then you would reduce that as well, and you still get the same answer. But look at how much work that is. You have to simplify, cancel, and reduce. So it's best to reduce first. Always reduce first. Okay, then number 19. They gave us two similar triangles. The perimeter is 30 and the perimeter, oops, is 90. Okay, so now what we could currently find is ratio of perimeter. All right, who's been paying attention? What should we do before we do anything else? What should we do? Yes, reduce it, simplify it. Nice. So that means this ratio of perimeter is 1 to 3, 1/3. That's not my final answer. Maybe missing triangle in the middle. Okay, I'm going to just copy and paste that, and I'll come back to that. Copy and paste. Okay, so to proceed for number 19, we have the larger area is given, and the smaller one we don't know. I put X. Okay, so I need to now, because I want to find area, I need to find the ratio of area using this information, 1 to 3. So now 30 and 90 is not important. So once you use it, it's done. So the ratio of area is 1 squared and 3 squared. That's not my final answer, but that will help us. So lastly, we're going to make a proportion. So with our proportion, we must use 1 to 9 because that's dealing with area. So meaning 1 over 3 we're not going to use anymore. 30 over 90 we're not going to use anymore. It's done. That was just to get 1 over 9. Then 1 represents the first picture. So X represents the first picture. And 9 represents the second picture. So 270. So from there, you cross multiply, do your math. I just noticed 9 times 30 is 270. So 1 times 30 will be X. So your area will be 30 square, whatever the units are, square centimeters. So final answer is 30. Okay. And then number 20, we did. Oh, okay. So let me do a couple more ratio stuff. I'm going to make it on the fly, so it might not be the best. Let's say, okay, the areas of two similar figures. One of them is, let me do a little bit of calculations. 98 square centimeters. And the other one is 128. So some kind of similar to the quiz. And then, however, we're going to find perimeter. And okay, now I have to think numbers. Hold on. Okay, so the perimeter will be, let's say 35. Hopefully my numbers come out. Okay, so step 1. We have to use this information because they're both given, and we can currently find ratio of area. So 98 over 128, if you've been paying attention, just like Kyle and Samantha replied on the chat box, you are going to reduce, or you are going to simplify. So there's a trick in the calculator. You could use this ABC button. So you put 98 ABC 128 and it reduces for you. I know I taught my students that, so they are aware, but if you are familiar with Texas Instrument calculator, you can use that. So that's the reduced version of the ratio of area. Then we need to find ratio of perimeter. You could do it for mixed too. You just have to push second ABC, Alexander. So then now you square root 49, or just change your mixed number to improper Alex. So then square root of 49 is 7, and square root of 64 is 8. So again, this is now used up. We're not going to use those numbers anymore. Okay, now we're going to make a proportion, and we're going to set it up. Proportion 7 over 8 equals 35 over x. So you could cross multiply, do all that jazz. This is what I do. I notice multiply the top by 5. So multiply the bottom by 5. So our final answer perimeter will be 40 centimeters or whatever units they give us. Okay, all right. Okay, now let me go back and answer a couple questions. I think Ryan earlier asked, can you do a problem where you had to look at the triangle in a different way? Oh, gotcha. So this was from, at least Tira, we had a mid-quiz. I don't think everyone had a mid-quiz. So let's say this is a right triangle. Okay, and let's find x. All right, let's make this 3 and 8, and this whole thing is 12. Okay, so step 1, let's find area. So step 1, these are 90 degrees to each other, perpendicular. So this is your base and height. So step 1, we're finding area. So that means the area is 3 times 8 divided by 2. That is 12. Okay, then now we have to look at it in a different perspective. There's another base and another height because they're 90 degrees to each other. So now I'm going to do it all over again, but now I have to input x. So I have the area, I have the base, but I don't have the height. This is B is, this is what I'm trying to, wait. Oh, sorry. This is 12. So then now I'm going to do half of 12, which is 6 in x, and then divide both sides by 6, and I get 2. So let's do the math again, okay? If I do 12 times 2, I get the same as 8 times 3. Okay. Same thing with the parallelogram one. That was on your old homework. You had like this weird thing that's sticking out. This is a parallelogram. Sorry, it's not the most beautiful. So the red that's not part of the parallelogram. Okay, so let's say I had 8 times 4. That'll give you the area, base times height, 8 times 4. So area is 32. Okay, but what if I put this length, and this length out here is 16 and h. So now I have to do area formula all over again, but now I have a missing variable h. So I have to look at it a different perspective, and I have 16 as my base and h as my height because they're 90 degrees to each other. Oops. And then my answer would be 2 in this situation. So it's just a matter of spinning the paper around or tilting your head around, but you have to find the area first of that shape and then turn your head, look at it differently, find another perpendicular sides. Okay, let me answer Brianna's question, and then I think I see area of a, what kind of polygon, Trevor? Pick a polygon. So hexagon, pentagon, one with trig. We didn't do any trig, guys. We didn't do any trig. Like pentagon, I'm hoping you guys are okay. Dodecagon, I'm hoping you guys are okay. We did not do any of this. Okay, we'll do pentagon. And then let me just answer some other questions from before. So Brianna asked, missing triangle in the middle. Brianna, you have to refresh my memory a little bit more. Mini quiz, missing triangle in the middle. Like, I don't even know what that refers to. So Brianna, you're gonna have to dig a little deeper. I will get back to your question. I'm not sure what your question is asking. Kaylee, the 10.1, this is yesterday's homework, the worksheet, I think. Shaded region. Okay, keep expanding, guys. So Sarah, thank you for that, but Brianna, keep expanding. I think this is what Kaylee is asking or referring to. If not, Kaylee, sorry, this is not the right one, tell me. Okay, so in this case, find the area of the black triangle, not the red, the black triangle. So because it's a triangle, we do 1/2 base times height. And then we would do 1/2, the base is 5, and perpendicular to that is 14. So in other words, we did not need the 17. That was there to kind of throw you off. So we take half of 70 and we will get 35. So hopefully, Kaylee, that was your question. I think it was the one that equals 98. Two triangles, both heights were 14. Two triangles, both heights were 14. And then it was equal to 98. Still a little lost. Had to find the area of the square and then subtract the area of the triangle. Oh, I get ya. Yes, okay, thank you. Yes. Thank you. So it was kind of like this, I think, right? Brianna and Sarah and Kyle were putting their heads together. Cool. So exactly what Sarah said, you have to do a subtraction problem. Here's why. I have no clue what this number is here. I don't know if that's 5 or 7. I don't know. I can't just do 1/2 base times height. Unfortunately, I'm kind of stuck in that situation. So what you have to do is you have to interpret this as the big square and then minus this triangle. So big square minus this upside down triangle will give you this shape, this leftover. That is what we will have to do. So step 1 is easy. The square is 14 times 14. So the square is 14 times 14, and that is a big number, 196. So that's the square. Then the triangle, the bottom is 14. That means the top is 14. The vertical is 14. That means the height of the triangle is 14. So we have 14 times 14, and you half it. So 1/2 14 times 14. That's the triangle, and that's 98. So if you subtract those two numbers, then you will get a total of 98, which ends up being the shape of the two triangles. So again, it's impossible to figure out these numbers, so we have to look at it at a different perspective. So thank you, Sarah, for that reminder. It is that square minus that upside down triangle. Cool. All right. I hope that helped. Okay, then pentagon. All right. And this might be the last one, just because I don't know what my time is, but it looks like this is the last one, 8 o'clock. Okay, so pentagon. So who asked this question? It was Trevor. Trevor, what do you want to be given? Do you want the A to be given? Do you want the R to be given? Do you want the side to be given? That's your choice, Trevor. It's your problem. Which one do you want to be given? Okay, let's do side. So let's make the side 14. Okay, so each side is 14. So the formula is 1/2 SAN or 1/2 AP. Same thing, exactly same thing, okay? So first you need to make a right triangle. Oops. So you would make a right triangle. And Trevor, are you okay finding this angle in here? So to find that angle in there, you would do either 180 divided by 5, or my class would do 360 divided by n, and then divided by 2 after. So 360 divided by 5, you get 72, and then you divide that by 2 after. So 36. Same exact thing as some teachers say 180 divided by n. Same exact thing. Okay, but I know my students do this method. So 36 is in here. Okay, so now what we need to do is cut 14 in half. So I have 14 in half, so that's 7 and 7. So all we need is the apothem. So if you redraw the picture, because it's now cluttered, this is 36, the apothem, and 7. You have to use SOHCAHTOA. So across from 36, that's opposite. Next to 36 is adjacent. That means this is TOA, tangent. 36 degrees equals, opposite is 7 over A. Cross multiply, you'll get A tangent 31 or 36 equals 7. Divide both sides by tangent 36 and you'll get the apothem. So now that's your apothem. So we're going to plug in everything. We're going to do, so Trevor, hopefully you have a scientific calculator, and hopefully you can type it in so you get that practice before tomorrow. So you do 1/2. Your side length was 14. Your apothem was 7 over tan 36. And then the number of sides is 5. So that one you could find the missing angle, which would be 44. Where's 44? Sarah, where's 44? Oh, 54. 54. Yes, you could do law of sines too. You could do law of sines, absolutely. Yes, that's okay. So type it in. I'm going to type it in too, Trevor. I know this was your question, and other people are good practice. 14, 7 divided by tangent 36, and times 5. And this round from here is 10th. It's in the 300s. 300s. I hope I typed mine in right. 300s. 300s. All right, I'm getting 330. Oh, no one's typing. Okay, 337.2, I believe. Let me double check all my math, all my calculations. Yep, 337.2. Just FYI, yes, you might have to do this where you have to find, let's say R would have been a little bit more intense if I did 14 for R. You would have had to find both the apothem and this side length, or like X, and then you'd have to double it. Like that's a little bit more difficult. I could have done that too. So that one's still 1/2 SAN, but you would do SOHCAHTOA, or you could do law of sine like Sarah suggested. But that one, I'm going to just go really fast, okay? For X, that would be sine, so that would be 14 sine 36, but the whole side length would be times 2, so that's 28 sine 36. Sorry, Trevor, I'm going really fast. And the apothem would have been cosine, so apothem is cosine, 28 cosine 36, and the number of sides is 5, so that's a little bit more intense. Oh, nope, this is 14, 14, 14, my bad. And then you multiply those out. If you want that practice for your calculator, type it in your calc. Sorry, that was really fast, but just because of time. Cosine 36 times 5. and this is in the 400s. How would you multiply A? Pardon? I don't understand, Beverly. The height is the apothem. This is the height of the triangle. So I did SOHCAHTOA. Let me start all over then. Okay. Maybe too fast was a mistake. Sorry. Okay, step 1. We need to find the A, which is the apothem, not the height. We're not finding height. So step 1, this is cosine 36, which is equal to A over 14. Cross multiply, you'll get A equals 14 cosine 36, and we're going to save that for later. Okay, that's the apothem, not the height, nothing to do with height. I would not be able to find height. That is not the goal here. Then I'm going to do this again. I'm going to erase this, and I'm going to find x. So to find x, I'm going to use sine, because it's opposite over hypotenuse. Cross multiply, I'm going to get 14 sine 36. But there's like 2 x's will equal 1 whole side length. So that means s is double 28 sine 36. I'm going to save that for later. And then the number of sides, we already know it's 5 for pentagon. So we're essentially finding the area of one triangle right here. This is what we're doing. We're finding 1/2 base times height of this triangle. Once we find the area of this triangle, there's 5 other ones. And that's why we multiply by 5. So 1/2, the base is this bottom, which is the s. So 28 cosine. Is that sine? Oh my gosh, sorry. 28 sine. I misread my writing. This is sine down here. Sine 36 times the apothem, which is the height of the triangle. Okay, but you'll never find height of the pentagon. And then times the number of sides, which is 5. So that answer ended up being 466.0. Final answer. Okay, whew, that was fast. I wanted just to at least expose just a couple of the trig type, but tomorrow your test, you will have probably about the same number of questions, like 19 or 20 questions, and a lot of the answers will be rads, a lot of the answers will have decimals. You know, sometimes you have to do Pythagorean theorem. We didn't do too much of that practice. So if you're missing information, you probably will do Pythagorean theorem. And let me post